Hi, my name is Garrett Van Beesler, and this is my PowerPoint presentation over unsaturated polyesters. What is a unsaturated polyester? It is a copolyester. That means they're polyesters prepared from a saturated dicarboxylic acid or its anhydride, as well as an unsaturated dicarboxylic acid or anhydride. These two acid constituents are reacted with one or more dialcohols, such as ethylene glycol or propylene glycol, to produce the characteristic ester groups that link the precursor molecules together into long chain-like multiple unit polyester molecules. These polyesters also can be used for many different applications, which we will talk to later. Its history. It's nearly a 100-year-old polyester, and it was first discovered by Wallace Carothers in the late 1920s. Early polyesters were sluggish in homopolymerization. They required high temperature and long curing times, and they were solid or had very high viscosity, which made them very immobile. Later on, in 1936, a man by the name Carlton Ellis discovered the addition of liquid unsaturated polyesters, and that reaped many benefits. It was a 20 to 30 times faster polymerization rate than UP resin alone. It was easily handled, and it didn't need high molding pressure. Leading into World War II, there were many discoveries during World War II on this polyester. One of those main discoveries was that glass reinforcement led to stronger properties for styrenated UP. Styrene became cheaper, and its resin types proliferated. Applications multiplied, and raw materials were available for manufacturing. It also was very lightweight and could be used for parts in airplanes, and it also had very good properties to be used for radars. It is made up of 3 parts: difunctional alcohols. Its main difunctional alcohol used for this chemical is propylene glycol, but also used are ethylene glycol, diethylene glycol, dipropylene glycol, 1,6-hexamethylene glycol. The next part is dicarboxylic acids, and its main one is isophthalic acid, IPA, and then fumaric acid, FA, in the trans form, and then maleic acid in the cis form. And then below in the image we can see many other acids used in this step. And then there's a reactive diluent added, and the main one is a very well-known one, which is styrene. Styrene is not the only one used, as scientists also use methylene methacrylate, MMA, or vinyl toluene. How it's made. The process is called polyesterification. Polyesterification is a typical condensation reaction carried out in a reactor with an accessory like a condenser for water elimination. It has 4 side reactions, that is isomerization of malleate to fumarate, addition of glycol to malleate and fumarate double bonds, oxidative destruction of double bonds, and the loss of glycol. How it's done? It is done in a blanket of inert gas, and the steps include charging the reactants. It is heated to 140 degrees Celsius while mixing continuously. The reactants are boiled. An inert solvent is added to distill off water. Temperature is then raised 190 degrees Celsius until the acid number reaches 38 to 45, and then we add a diluent. In easier terms, it is UP alkyd plus reactive diluent equals UP resin. Applications. As said a little bit ago in the introduction, it has a very, very wide range of application, and these include sanitary ware, tanks. You can see those tanks in the picture, but it can also be used for bigger tanks, piping, gratings, boat hulls, decks, and body panels. Many companies still use this resin today. Some of these companies include Ashland, Reachhold, and Royal DSM. In conclusion, this is unsaturated polyester is a very good resin to use. It has a very wide range of applications. It should not be overlooked and is almost a century old, and I don't think it's going to stop slowing down. These are my references, and thank you for listening.